So with that, let's turn it over to Liam, and we'll get started. Does that sound good?
Yeah.
Thank you very much.
There you go. Thank you. Lovely. Good morning. So, as Tom said, I've come over from wet and windy Ireland to tell you about something pretty cool. And we think it's one of the most exciting things to happen in automation connectivity since industrial Ethernet. So I'm Liam Power. I'm the Technical Director of Embedded Labs. And I'm also a member of a number of working groups in the OPC Foundation and the Technical Advisory Council also. Embedded Labs is an Irish software company. We're around about 10 years, and we're a corporate member of the foundation. But what does that have to do with about OPC? Well, Embedded Labs is the single source for OPC UA technology that allows you to put an OPC UA server on a chip that costs less than $5. We're a software company. We don't provide the chip. But if you tell us what chip you want to put it on, we can put it on there. So OPC UA is all about converting data into information and moving that information securely to wherever you need it to go. So it's all about connectivity. But why do we need connectivity? Well, we need to download production lot and batch information. We need to control our processes and equipment. We need to visualize our processes in order to supervise and control them. We need to log and archive data in order to comply with regulatory requirements and to analyze historical behavior. We need to generate reports so that we can keep line management updated on what's happening in the plant. And via logging and reporting, we need to analyze performance so we can maximize our productivity using metrics such as OEE. So that's why we need connectivity. And we'll have a quick look now at some examples of how we provide connectivity in a plant today. So here we have a typical industrial automation architecture. At the top, we have the IT layer. We have an OPC client application server, a HMI, an MES, and we have an industrial Ethernet to OPC driver, which is effectively middleware that provides a protocol mapping from the shop floor up to the IT systems. Then if we look at the bottom left, we have an island of automation, which is basically based around a micro PLC whose only means of connectivity is a serial field bus. And what we've done here is we've installed a PC running middleware in order to convert that serial field bus information up to OPC Classic. On the right-hand side, we have a slightly more modern example where we have an industrial Ethernet I/O block. It could be Modbus TCP or something like that. And we have this Modbus TCP communication up from the I/O block to, again, driver software up at the IT layer, which converts that to OPC Classic. So, these are two fairly typical examples, and, there are quite a few limitations of this approach. If we take the case in the bottom left first, we've taken a PC, as I said, and we've put it down here in order to provide connectivity. Obviously, there's capital cost associated with the PC. There's the configuration management and maintenance of the software. You have virus issues, stuff like that. You've put a PC down on the factory floor, which means that you now have to negotiate with the IT department to provide support. And if anyone's amongst you has tried to do that, you'll know that it can be quite a painful process. Also, the middleware that maps the serial field bus data to OPC Classic can at times, depending on what the field bus is, be quite labor intensive and complex to configure. So you have capital cost, you have configuration costs, and you have ongoing running costs. If we look at the more modern example on the right-hand side, where we actually have Ethernet all the way down to the cabinet, there are still problems. We don't have the capital cost of a PC, or we don't have a PC on the shop floor, but we still have to buy the middleware that converts the protocols. Also, we have insecure connectivity over Ethernet from the shop floor up to the IT layer. So if we have an attacker who's compromised our network boundaries, he can potentially eavesdrop on that traffic and, worst case scenario, even actuate equipment on the shop floor. So I think you'll agree there's room for improvement. So with OPC UA, how will we provide connectivity tomorrow? We're going to look at a couple of examples of what we can do. In this first example, what we've done is we've replaced the PC on the shop floor with a robust embedded gateway device which maps the serial field bus data to OPC UA. Now, this wasn't possible before because OPC Classic, as Tom mentioned, is a Windows-only technology. But with OPC UA, we can take a tiny little robust embedded device and put the protocol mapping on there. So we still have to configure that gateway. But now we have reliable, low-cost industrial electronics. We've eliminated the PC. We've eliminated the middleware. And we don't need IT support. So it's a huge improvement. Or maybe, if in the case where you're retrofitting onto an existing system, this is something you might do. But if you're putting in a new system or a new piece of equipment, maybe you can go better than that and get rid of the gateway altogether and purchase a PLC which actually has OPC UA directly embedded inside it. Now, as I said before, to put OPC UA in a device, you need a chip that costs less than $5 in quantity. So if you can afford to put industrial Ethernet onto your micro PLC, it really doesn't cost you anything extra to add OPC UA on there. Another advantage of both of these approaches is that we can now have secure communication, so that's authenticated and encrypted communication, all the way from the cabinet up to the IT layer. So if we take the example of the I/O block, we can also improve on things here. If we embed OPC UA directly in that I/O block, no significant bill of materials cost increase potentially, and we now have secure communication directly up to the IT layer. And not only that, we don't have to buy and configure the middleware anymore. So instead of trying to map, for instance, with Modbus TCP, unstructured register-based data to OPC Classic tags, we now just point and click and select the tags that we want. And there's very, very minimal configuration, so it saves a hell of a lot of time. But we can even do better than that. Why not put OPC UA directly in the sensors? So we can create a sensor network of smart sensors, put it directly in actuators. In many cases, this delivers similar functionality to more typical architectures with a much lower cost for the end user and much less configuration. Obviously, there are places where you can't do this. If you're trying to close a control loop over a deterministic field bus for motion control or something, you're not going to do that over OPC UA. But there are numerous examples where you don't need that kind of functionality at all, and this is really, really a great solution. Another point I should mention is that in order to reduce the unit cost of some of these sensor devices, the UA servers that are embedded in them will have some limitations. So for instance, they'll only support a small number of client connections at a time. So in certain applications, that's fine, that's all you need. But for some applications, you may decide that you want to aggregate that information through a single point in your IT layer. And if you want to do that, you're going to need some kind of aggregating server. Again, there's very little configuration because you're not mapping protocols. You're just point and click, selecting the information you want. And the really good news is that if you do decide that aggregation is something you want or need to do, if you use an Iconics package, for instance, like Genesis 64, you don't even have to buy third-party software to do aggregation because Genesis 64 comes with aggregation for free. So if you have 100 sensor, a sensor network of 100 nodes, and you want to connect those to an alarm server, you want to connect them to HMI, you want to connect them to a historian, and you're using Genesis 64, it just creates one session down to the sensor. So you don't even have to buy any third-party software. So also, some MES vendors, as Tom mentioned, are adding OPC UA to their plant connectivity products at the moment. So for the first time, we have the potential here to use a technology which is easy to use, configure, secure, and to use the same technology from the shop floor all the way up to the top floor. So this is it. This is potentially, for many, many use cases, the industrial automation architecture of tomorrow. Very, very cost effective, very easy for end users to use. And based on our market research, I'd like to make a couple of predictions. The first prediction is that in 8 years' time, less than 1 in 1,000 UA servers sold will be sold on a DVD or as installable software. Now that sounds like a bold claim. I'm not saying that the existing OPC server, the PC-based OPC server market is going away, because it's not. It's probably going to continue to grow. But the embedded market, where you don't buy server software, you buy a device which has a server in it, is going to grow so exponentially that it's going to completely dwarf the OPC classic market that we've seen over the last 15 years. The second prediction I'd like to make is that, again, based on our market research, within 8 years, the installed base of embedded OPC UA devices in industrial automation alone will exceed 50 million units, and it will be growing exponentially. There are also huge opportunities for UA in building automation, energy management, because typically these requirements exist on the one site and people are tired of using different disparate systems in order to pull them together. So there's convergence there, and there are different protocols competing for that space, but given the benefits available from OPC UA, we're quite confident that there'll be some success in that market also. And finally, I'd just like to leave you with a little bit of news, and this is the first time this has been announced publicly. For the last 12 months, OPC UA has been available on a sub $5 chip without security. But in 2012, it'll be available with full security on a chip. Initially, it's going to be, you'll be able to put it on a chip in the $5 to $6 range. So we have an example here. It's an ARM chip from ST Microelectronics. But it's multi-platform software. It'll go in a lot of different places. And thanks to Moore's law, these price points are dropping all the time. So if it's $5 to $6 in 2012, next year, it'll be less than that, and next year it'll be less again. So that's it. I hope I've given you a little bit of a feeling for where we think the trends are going to go, and hope you enjoyed the rest of the workshop.